Acha, you do not have any doubt in this, na? Rolling without sleeping? No one. Radhika, okay, na?
Yes, sir.
Shama, you? It's okay, na?
Yes.
Rolling without sleeping, na? Okay. Now, let me give you some questions regarding this. I'll start from easy one and then we'll move on to the tough one. This is the easy one. It's not based on rolling without sleeping. It's actually based on conservation of angular momentum first. Diva and Kanishka, I have just given this question. Only this question, na? I have not taught anything new. I've given this question to solve. This is a question based on conservation of angular momentum. It's a very big hint. It's based on law of conservation of angular momentum. Today Haripriya is absent. Haripriya. Okay, she's not well. Are you able to understand the question? Do you have any doubt? Radhika, Diva, Kanishka, anyone? Let me give you some time to solve. Hello, hello, hello. Achha, my sound is audible, na?
Yes, sir.
Hello, hello, hello. Okay. Do you want me to solve it?
My answer is coming as C part.
Your answer is C part.
Yes, sir.
Achha, let me see. Very good. It's easy question only, na? Not difficult.
Okay.
ठीक है. अच्छा. Okay, C. Let me solve it.
मेरे को बस इतना काइनेटिक एनर्जी वाले फॉर्मूला पुट करना था 2 3.
It's actually not that difficult. Because see, let me explain you the situation first. The situation is there are actually two disks. One disk is this one, and they are actually collinear disks. Collinear disks means what? These kinds. Yeah. Okay. Their centers are same. Actually, I wanted to draw this one. Has to shift it, I guess. Okay. This has a moment of inertia I1 and it's rotating with angular velocity omega 1. This has a moment of inertia I2 and it's rotating with angular velocity omega 2. Now, what happened after this? After this, they are combined. Now, they are combined like this. This and the like this it has been done. So now they are combining with the combined angular velocity. Now what we will do, because there is no external torque acting on this body, on this system. So what will happen? There is no external torque because only torque will be acting because of the friction between the two disks, and they will be cancelling each other. So in that case, we can conserve the angular momentum. Angular momentum initially was I1 omega 1 plus I2 omega 2. Now when they are combined, their combined moment of inertia I1 plus I2, they'll combine and they'll move with the same angular velocity. The combined angular velocity has become I1 omega 1 plus I2 omega 2 divided by I1 plus I2. This is the thing. Now, after you have found out the combined angular velocity, they are asking you the kinetic energy of this one. So the combined moment of inertia is I1 plus I2. So the angular velocity, kinetic energy is only
There's
rotational.
law of conservation of angular momentum.
Law of conservation of angular momentum only. Because there is no external torque. So the kinetic energy that you will be using is half I omega square because it is completely rotating, only rotation. Put this value and get the answer. It will be half into I1 omega 1 plus I2 omega 2 whole square divided by I1 plus I2. That's the answer. I thought it will be easy for you. It should not take this much time. Okay, easy for everyone. Understood? Now try solving this question. It was asked in IIT 1998. For this, I'll be giving you question on rolling without slipping. हाँ सुनाई दिया राधिका.
एक सेकेंड. बी पार्ट है क्या?
कौन सा बी पार्ट?
हाँ.
देखता हूँ रुको. डी नहीं है, डी है, डी फॉर दिल्ली.
बी बोला.
हाँ सही है, करेक्ट है, वेरी गुड.
वो मैंने उल्टा कर दिया थोड़ा सा, उसको उल्टा है.
Radhika has got the answer. So let me solve it. I think the others are not able to solve. See, let's understand the question first. The question is saying a smooth uniform rod of length L. This is the rod. Its length is L. L by 2 both sides. Its mass is capital M. Has two identical beads of negligible size. These two identical beads are there. These two. Each of mass small m. Their mass is small m, which can slide freely around. Initially, the two rods, two beads, are at the center of the rod. Initially, they were at the center, and the system is rotating with the angular velocity omega naught. Initially, the angular velocity was omega naught. Now, perpendicular to the rod and passing to the midpoint of the rod, there are no external forces. When the beads reach the end of the rod, the angular velocity of the system is. This is very easy. See, the situation initially is there is only rod which is rotating. So law of conservation of momentum will be there. Why? Because no external torque is acting. Law of conservation of angular momentum. Initially, the moment of an I1 omega naught is equal to I final omega final. It's vibrating. Okay. Now, initially, the moment of inertia is only due to rod because these two masses are at the center. So these two masses, because the distance from their axis is zero and negligible, so their moment of inertia won't be there. So it will be, and the moment of inertia of the rod about an axis passing through the center is, we remember that result.
ml square by 12.
Very good. So it will be ml square by 12. This one. Now, ml square by 12 is there plus 2 into m into 0 square initially. Now, finally, when they have moved to the ends, these ends, one end is one on this end, one on this end, then their moment of inertia will add up. Now the moment of inertia will be ml square by 12 of the rod plus 2 into m into L by 2 whole square, because each bead of mass m is now placed at this position, new position, L by 2. Here, here. So their moment of inertia will add up. So this is ml square by 12 and this is ml square by 12 plus 2 ml square by 4 means ml square by 2. M plus 6m into L square by 12. Now simply you have to put it in the first equation, which is ml square by 12 into omega naught is equal to m plus 6m into L square by 12 into omega f. Cancel these out. L square, L square. So your answer will be omega final is equal to m omega naught by m plus 6m. No option? D. Yeah, D is the option. I don't think these questions are tough. I have not yet given you any tough question. They're not tough. They're just for you to gain the momentum. Means you have to gain the momentum. You have to understand how the conservation of angular momentum is being applied. And remember, it is an IIT JEE question 1998. Then how easy questions were there, you see. Okay, na? Easy for everyone. Understood this one? Shyama, okay?
Yes, sir.
Easy, na? Shyama, okay. Kanishka, Diva, Radhika has solved. Okay, everyone?
Yes, sir.
Yes, sir.
Okay. Now try to solve this question. This is also not that difficult. It's easy only. After this, the question that will come is a little bit good quality question. That question will be based on rolling without slipping. And then after this, I'll give you a pulley question. There you will understand when there is a friction in the pulley, how things change. Eh?
3v by 12.
3v by 12. C. Correct. Only Radhika is able to solve questions quickly. Let me ask others, what difficulty you are facing? दिवा समझ में आ रहा है क्वेश्चन? इस क्वेश्चन को समझ में आया कैसे अप्रोच करना है?
सर आ तो गया बट नहीं से अप्लाई नहीं हो रहा है
अच्छा,
जो
अप्लाई नहीं हो रहा है अभी को. व्हाट अबाउट श्यामा?
तो लास्ट क्वेश्चन जैसे ही है ना,
हाँ, ये लास्ट क्वेश्चन में
ऑलमोस्ट सेम कॉन्सेप्ट ही अप्लाई
So
हो
you
रहा
have to
है.
use law of conditional momentum and that law of conditional random momentum.
हाँ, but still you have not got the answer ना.
I'm trying it kind of.
You know
I'll
the
try one more time.
What about Kanishka? See how the question is solved na. It's again based on conservation of momentum, but how it will be seen. This is your rod.
It'll be mv equals m plus the mass of the bullet because it gets embedded, right?
M
Rod is at rest, bullet of mass m into v, and then rod is also a mass so 2m into v common. We'll move it there.
there is no translation motion na. It's rotating only.
Oh, okay.
It's not translating. It's only rotating. See how the things are. Moment of inertia of a uniform rod of mass m. This is m. This is L. Mass total length is L. Through the center and perpendicular to its length is given by ml square by 12. This moment of inertia we know. It's why they gave, we don't know. Now consider one such rod pivoted at its center, free to rotate in the vertical plane. The rod is at rest in the vertical position. This position it is at rest. It's free to rotate about the center. A bullet of mass m. Now from here, the bullet came. Its mass is capital M. Moving horizontal with speed v. Strikes and embedded in one end of the rod. This strikes and gets embedded into the rod. After the collision, it sticks into it. The angular velocity of the rod just after the collision it wants. Now see, here we can apply the conservation of angular momentum. Because we can apply the conservation of linear momentum here in this collision cases. But here, since it is rotating only, after the collision, this rod will be only rotating because it's pivoted at the center. We will have to apply the law of conservation of angular momentum. Now, before collision, what is the angular momentum of this mass? I told you the angular momentum is mvr, mass into velocity into perpendicular distance, or I into omega. Both are same. So before collision, the mass of the angular momentum is mv into L by 2. This is for the bullet only because only bullet is moving. After collision, the bullet gets sticked into it, and then after sticking into it, this whole part start rotating. Now it will be I into omega. That omega angular velocity only we have to find. What is I here? I will be after this bullet got stuck at one end. The moment of inertia of this system will be about the center. It will be ml square by 12. This is the moment of inertia of rod about the center. Now plus of the bullet, it's m into L by 2 whole square. This only m into v into L by 2 is equal to ml square by 12. plus m into L square by 4 into omega. Solve it and get the answer. This m will cancel. L will cancel again. 4 by 12, it's v by 2 is equal to 4L by 12, which will be 1 by 3, L by 3, so 3v by 2L is the angular velocity. This is the answer. Okay, दिवा समझ में आया?
See, तो आगे समझ रहे हैं. But when like I took the bullet as and the rod as one system, and then I thought that the bullet will go in translational motion only, so it got mixed up.
See, when it got attached, when this bullet got attached to the rod, and this rod is capable of only rotating about this this O point because it's pivoted, means इसको लगा दिया है, मतलब फिक्स कर दिया है यहाँ पे बीच पॉइंट से. When you have fixed it from the middle, it cannot translate na. It will only be able to rotate like this. It's like this. This is pen and it's able to rotate like this. That's all. So when it is rotating, because your bullet is also attached to one end, it will also be rotating with this. There is no point of translation. That the same thing Shama was doing. You both did not focus on this point. It's pivoted. How you will do this question? It's a bit tougher. See, size. This question is for rolling without slipping. Translation plus rotation both. Just try to understand the question. If you are able to get the idea how to solve it, solve it. If you are not able to get any idea, I will solve it. Just tell me, sir, we are not able to. Are you able to understand it, or it's a bit difficult? At this point,
I'm able to understand.
able to understand, na? Getting the idea?
I'm not able to see.
Not able to. Diva is able to understand. What about Kanishka and Shama? They too don't have idea. See how we will solve this question. A solid sphere of mass 5 kg and radius 1 meter is kept over a rough surface. A force of 30 newtons is acting at the topmost point. See, whenever a force is acting at this top point, its first tendency, you have to see its first tendency. If the force was acting at this particular point, this point, the only thing it can do about the center is translation, because there won't be any torque about the center. But now when this force is acting at the top, the thing that it can do is, the first and foremost thing it will try to do is apply the torque about the center. Now when it is about applying the torque, the ball will try to rotate, solid sphere will try to rotate in clockwise. Means the bottommost point has a tendency to move backward. So that's why the friction force will be acting towards front. This is actually very important reasoning that I have done. You have to always check the first tendency of the body. If the force is acting at the top, it's applying the torque. So the first tendency of the body is to rotate, and accordingly you'll apply the friction force. If the same force was acting at the center, then it had the tendency to move forward translationally, and the friction force will act backward in that particular case. Okay. Now let's solve it. Now for the first answer, check whether the pure rolling will take place or not. It will, because see, what will happen, it's rotating with angular velocity omega. It's having the angular acceleration alpha also. Now because of this friction force and this capital F, over the period of time, it will gain some velocity also. It will gain some velocity keep on increasing, omega will be there. So there will be a point when this velocity at the bottom of the bottommost point V, translation velocity, will be equal to its rotational velocity r omega. So at that point, the pure rolling will take place. So this option is correct. Pure rolling will take place or not? Yes. Radhika, okay? समझ में आया? Understood?
Yes, sir.
So it can do the pure rolling. Now find the direction and magnitude of friction actually acting on the sphere. Direction of the friction force we have actually found, because the first tendency of the body is to rotate. Then the bottommost point will be having the velocity towards the back. It will be r omega initially. So it is slipping towards the back. So the friction force will be acting forward. Magnitude we have to find. So for finding out the magnitude, how we'll do, for pure rolling they are asking. So we'll frame the equation how.
V equal to r omega condition भी
हाँ वो लगाना है। पर तुम दूसरी भी लगा सकते हो, इज इक्वल टू आर अल्फा। अभी मैं सॉल्व करके दिखाता हूँ। पहले टॉर्क की के लगाते हैं। टॉर्क इक्वेशन F इंटू आर माइनस स्मॉल f इंटू आर, सेंटर के अबाउट निकाल रहा हूं, अबाउट सेंटर is this is equal to I into alpha. This first equation. It's solid sphere. I can use 2 by 5 mr square. I is 2 by 5 mr square. So this is first equation. F minus f into r 2 by 5 mr square into alpha. R you can cancel. So f minus f is equal to 2 by 5 mr alpha. Now translation motion, what I can do, because there are two forces, one is capital F, one is friction force. Because of this, these two forces, it will have the translation acceleration also. It will, when it will move, start to move with the translation motion. So in that case, translation motion, I can have capital F plus small f is equal to mass into acceleration. This is my second equation. Now, you know, for rolling without slipping or for pure rolling, we understood in the last class V should be equal to R omega because bottommost point should be at rest, or A is equal to R alpha. To differentiate it, we'll get this. So we'll be using this condition, A is equal to R alpha. Now you can solve 1, 2 and 3 to get your desired result. Friction we can find, A and alpha we can find. See, I'll show you how we'll do it. From first equation, capital F minus small f is equal to 2 by 5 m A. Capital F plus small f is equal to ma. So add them to solve. 2f is equal to 7 by 5 ma. So A is equal to 10f by 7. Acceleration we have found. Angular acceleration we can find now because A is equal to R alpha. So alpha is equal to A by R. That means 10f by 7r. This is the second answer. This we have found angular acceleration. Magnitude of friction they want. So either you use second equation, I'm using second one. Capital F plus small f is equal to m into 10f by 7. Something I am doing wrong. M I have not divided, no? Okay, now okay. I did not divide M because 10f by 7. Now mm you can cancel. It will be f is equal to f minus 10f by 7. So minus f by 3f by 7. Friction force is coming towards back. Okay. This is how we solve it. Torque equation f into r minus Correct only. Friction force should not come negative. Who is alpha? Okay, no problem. Means at the time of pure rolling, the friction force will again go back to back direction. Understood now? This is how we solve the question.
Okay, sir.
Okay. Anyone has doubt? No? Diva? Okay, understood?
Yes, sir. We are saying that friction will act forward. That is only for that instant.
For that instant. Because you see, it's not necessary that friction force will be always acting towards the forward direction. It will keep on changing its direction depending on the velocity, depending on the situation. Means if the V is greater than r omega, at that point the friction force will act backward, and then when V is equal to r omega, the friction force won't be there. If V is less than r omega, then friction force will be acting forward. Friction force changes actually. Okay. Should I move on to the next part? See, the one more important question I wanted to show is this one. Only 5 minutes are left. Let me show you. This is actually very important one. See, up till now, you have understood that friction, that whenever on a pulley something is kept, the string is moving, friction is not there, it's just keep on slipping. That's how we have understood. But now things will change. How I'll show you. This question I'm giving. Try to understand this one. See this one. See why this question is important. What's the difference? Let me tell you. First, read this question properly. I'll explain you because time is left. I'll explain it properly. What the situation is. In the arrangement shown in figure, the mass of the uniform solid cylindrical pulley. This is a solid cylindrical pulley whose moment of inertia you can take as mr square by 2. Now, masses of two bodies are equal to m1 and m2. The thread slipping and the friction of the axle of the pulley are supposed to be absent. Friction is not there at this point, and the thread is not slipping at all. Find the acceleration of cylinder and the ratio of tension. See, here in this case, what is different? You used to take equal tension at every point, but here tensions will not be equal. Earlier, what used to happen when this was there was no friction between the. Here, what is the difference now? There is friction. There is friction between rope, thread, and pulley. Due to this friction, earlier there was no friction in the Newton's laws. So the pulley was as it is, it was not rotating, and the thread just kept on slipping. And there, because the friction was not there, the tension on the two part was also equal. Now, what will happen in this situation, when friction is there, the pulley has to rotate. It's rotating with angular acceleration alpha, and the tension in the two parts are different. So here, but acceleration of these two blocks will be same, because the distance by which M2 is moving down, M1 will move up because the pulley is inextensible. But the different, so how the equations will form? See, I'm framing the equation. You think over after the class, and then in the next class I'll solve it properly. What the forces will be, how the equations will form. For M2, M2G will be there. One tension T2 upwards. The equation will be M2G minus T2 is equal to M2A. Similarly for M1, M1G is downwards. T1 is up. So the equation will be T1 minus M1G is equal to M1A. Now coming to this pulley. Okay, very important. See, this is important. When we talk about a pulley, this pulley has a tension T1 on this side, tension T2 on this side. It has a radius, it's rotating also. So I'll make an equation T2 into R about, I'm taking torque about the center, minus T1 into R is equal to its moment of inertia into alpha. Now, since this point, there is one more important point. Since there is friction and there is no slipping of the thread and the pulley, at this particular point, I'm just making the equation. You have to understand these equations at home. At this particular point, the acceleration of the rope is towards up. It is also rotating. The acceleration due to the rotation of the pulley is R alpha in this direction. Also, this pulley thread is also moving up with the acceleration A. So these two accelerations should be same. Similarly, here also the acceleration of this point is R alpha, but this thread is moving down with the acceleration A. So A should be equal to R alpha. Otherwise, there will be slipping at the point A and B. These are the four equations using which you will be getting the value of T1 and T2. Now, you have to think over how I framed this equation And if you have any doubt, ask me in the class. In the next class, how I made these equations, try to think over. And if you have understood this now, find out T1, T2 and the ratio T1. You can solve them and find out the ratio T1 and T2. I you have to take as mr square by 2 because it's cylinder. Okay, understood everyone? This is only tricky part because this thread, this thread, this one, thread is moving up with the acceleration A. Also, this point of the pulley is having acceleration R alpha. So, if there is no slipping, the acceleration of the string should be equal to the acceleration of this point A here. Similarly, the thread is moving down with the acceleration A here in the right part, and this pulley is also this point is also having the acceleration R alpha. So these two should have the same acceleration for no slipping. Okay, let's end it. Anyone having any doubt? No, na?
I'll try this question again at home once.
You try this question again at home once, and then after if you are not able to understand, ask me in the next class, or you can WhatsApp me also. Send it. Bye bye. Good night.